every year around about 2 gigawatts. This peak always occurs around Christmas, and the maximum in-feed or installed power is around about 6 gigawatts. And of course, this is a big challenge for the dimensioning of our systems. And one result of this high installed power in our system is that we have to challenge a lot of feed-in management. And here you can see the development over the last 10 years. You can see the numbers of interventions that our control center has to manage over the years. And you can see that there's a very high rise. In 2009, the number was around about 50 interventions per year. Now we talk about around about 3,400, 500 interventions per year. And the congestions that lead to these interventions mainly are located in the higher voltage levels. Around about 95% of the interventions are caused by 110 kV and transmission level. That's not our system. Only around about 5% per year is caused by congestions that occurred in our voltage levels. And that's, of course, a big challenge for our operators. And here you can see on this chart what this means for questions of dimensioning of our system. Here you can see the utilization of some transformers between our 20 kV level and the 110 kV level above our system. And you can see a lot of transformers in our area are dominated by the renewable in-feed and not by the load. So in the past, around about 20, 30 years ago, our system, of course, as every system in Germany, was completely designed for the maximum load. Today we have the situation that the whole system is dimensioned, of course, for the maximum in-feed of renewables into the system. And our whole area today is working like a regional power plant, because the amount of power that is exported into the higher voltage level is much higher than the amount of energy that we get from the higher voltage levels. And to handle these situations, we begin more and more to install automation systems. Automated grid management is, of course, the technology that helps us to manage this. On this chart, I just wanted to show the principle of change of energy systems that we are faced with. In the 30 years, 20 years ago, we had a very simple system where, of course, as you all know, only big power plants and the transmission systems produce the energy, and this was transported through the transmission system into and the distribution systems to the customers. The power flows had only one direction, from the top to down. And today we have a completely different system where that gets more and more complex. Since many years, of course, in the north of Germany, we are faced with a lot of wind power, and also we have lots of solar power today. The installed power of solar-based in our system is around about 2.5 gigawatts today, and the wind power is around about 5 gigawatts. And of course, there are a lot of new challenges. We have also beginning the e-mobility in our system, of course. We have many new technologies concerning sector coupling, and one new technology that we are of course faced with is our heat pumps, and a lot of other things, and some numbers that you can see what happens on our system. We have today we have installed around about 500 AVR controlled transformers between the 1 kV level and the 20 kV level, because in distribution medium voltage grids with and low voltage grids with a lot of solar power and wind power, we have problems and challenges concerning voltage levels, voltage control. And during the next years, until 2032, we have to install around about 1.1 million smart meters into our system. We have renewables, I already told you. We have until today, this is the number of last year, we had around about 1,000 charging stations already installed into our system. I think the number today is already much higher, because there's a very fast development in our system. And some years ago, and since 2016, we installed systems for our 3% approach. That means intelligent dynamic curtailment of renewables to increase the amount of renewables that we can install into our existing system, and to prevent the to build always new grids for new installed renewables. On the next chart, I want to show you that new technologies concerning smart grid technologies, like AVR controlled transformers for the distribution system, and also automation systems, etc. There is, from our point of view, there exists no technologies that could be used for the whole grid. From our point of view, we say that every distribution grid has its own challenges. So what we do is we analyze always the status quo of our system. We identify potential, in the next step, potential solutions that could help us, for example, to optimize voltage control. Then we challenge different technologies that could be used, do simulations of representative grids, and then during through an evaluation process, we cluster our networks and look in which cluster is which technology the best solution. So the lessons learned during the last years was that the best technical solution depends on local aspects, voltage level, urban framework, and the amount of renewable distribution. And the base for an intelligent distribution network always is a sufficient share of measurement equipment, especially at the medium voltage level. During the last years, we concentrated or focused our development on the medium voltage level, because we were faced mainly with wind energy in feed. During the last few years, we also see that the low voltage level gets much more complicated. And we see that during the next years, we will see that e-mobility will rise very high. And the next step would be that the electrification of the heat sector, that will be a big challenge and leads to the need of new technologies in the grid. On this chart, I would like to show you that we have very big challenges on the way of energy transition in the next years. Can you already see and hear me? Because I have some...
We hear you well.
Okay.
You hear well, and you should speed up. 5 minutes left.
Okay, I speed up. We have not only the electric power system, we have also the traffic and the heat sector. And in Germany, we have round about 48% of renewables in the electric power system. But we have only round about 20% renewables in the heat sector, and we have near to no renewables in the traffic sector. And that's the big challenge for the future, and mainly for the distribution grids, that we have to bring much more renewables into the system so that we are able to supply the heat, also the heat and the traffic sector from the electric power system with renewables. And one question is, for example, will the system be completely electrified, the heat sector, or will there be hybrid approaches in the heat sector that we see? And we are very sure that we will not see an all-electric world. We are sure that there will be some kind of sector coupling with all, where in the heat sector, for example, hybrid systems in existing buildings will dominate the system, where gas condensing boilers will be combined with heat pumps, because the challenge for an all-electric heat sector would be very, very high, and the complete electrification with heat pumps only would be a very technical high challenge for the electric system, because the electric power amount of energy and the power that you need in the winter months would be so high that the distribution grids would be rebuilt completely new. And so we say it would be much more efficient if we use hybrid systems where we use the existing gas grids, and these existing gas grids could be dominated by biogas, so that it's completely climate neutral. And by combining biogas with heat pumps, you can also get the environmental energy into the system, like in the all-electric approach. And another very important question is the flexibility in the system. And here I want to show you that during the next years, most of the flexibility will be located in the distribution system and not anymore in the transmission system, because all the energy resources, renewables, will be mainly dominated, and like today, in the distribution system, and also everything concerning sector coupling will be located in the distribution system. And how to manage this? First example I wanted to show you is our Syntec project in ERA that ends in this year. There we installed a lot of measurements and automation systems and medium voltage grids to control all the distributed energy resources and flexibilities in the system, and bring them to into a completely new control system, where we implemented, for example, the 3% approach for dynamic curtailment in some medium voltage grids. We also implemented new concepts for voltage and reactive power control. We implemented and tested some predictive grid control systems for preventing congestions. And we tested the integration of storages and flexible loads. And this chart I wanted to show you as an example where we tested what we could do, for example, with medium voltage grids concerning reactive power control. And here you can see a system that we tested where we use wind generators that are connected to our medium voltage grids to optimize not only voltage levels in our grid, but also the reactive power balance of the completely medium voltage grid. And this has a very high potential for execution of set points from TSO. And that's the idea that I wanted to bring you today, that we have, as a distribution system operator, have the idea that in the future, our medium voltage grids can be operated like regional power plants, where we can, will be able to operate or execute set points for reactive and active power at the connecting points to the 110 kV level. So I think by automating the systems and use all the flexibilities that we have in the future in the distribution grid, we will be able to do this and to automate, to rise the automation level to a region where we are able to do this. And an actual challenge for us is concerning the about redispatch 2.0. And in redispatch 2.0, we have today already the challenge that we have to operate our distribution system in the future, in the next year, by completely new systems where we have to be able to do redispatch and to have a look into the next few hours for our distribution system, and not only like today operate only real-time congestion management. And this predictive congestion management today is only operated in the distribution grids, and from the end of next year on, we will be we have to be able to do this predictive congestion management only not just also in our distribution grids. And for this new challenge, we have to install already a lot of grid controllers in our system to do this. Okay, I think the 5 minutes are already exceeded. So here on this chart, I just wanted to show you how the grid control system is today in our area. We have wide area network that is constructed like this, and you can see there are only there's our main control system located in Oldenburg, and we have connected only stations in the medium voltage level today. And in the future, this will look like this, because in the future and then during the next years, we have to connect millions of smart meters on the one hand, and because of redispatch 2.0, we have to connect also around about 65,000 renewable energy resources, because redispatch 2.0 means that every generator has to be connected to the system, not only like today generators with installed power more than 100 kV, even all the small generators have to be connected to the system. And that's a big challenge for us and changes our system completely. Okay, that's it. Now, I think this was my last chart. Thank you very much for your attention, and I look forward for your questions.
Yeah, thanks, Enno, for this very interesting presentation, and especially the last slides should be of interest for especially for the TSO level, and for us as which are working on the question how we or what we will face out of the DSO level in the coming decades, and how to adapt the existing models to these challenges. So we have, I think, 5 up to 10 minutes left to for questions. So if you want to ask something, please raise your hand, and if you are able to put on the camera, it would be nice to get a little bit more, the feeling of being not so virtual. So hands up if there are questions. Please ask your question, and we have some time left to answer. At the moment I see nothing. Yeah, David, you are able to put on your unmute you. Okay, please ask your question.
Can you see me?
Yes.
Hello. Thank you very much for the nice presentation. It was very interesting. I'm currently working on long-term planning for distribution systems. Okay. And I'm very much interested in how you consider the operational aspects in the long-term planning, because as far as I know, these formerly separated worlds are merging now, especially with Einspeise management or feed-in management, curtailment, flexibility, etc. So in the methodology you showed, it would be very interesting to see how you consider operational aspects. For example, also another thing that is related to that, simultaneity factors that have been before post-X analysis of what happened in the grid, with new operational ways of operation. They get kind of controllable in a way, right? With demand response and flexibility. And for long-term planning, well, for medium-term planning, that would be very interesting how you consider the operational aspects. And for the long-term planning, also it's a separate question, but your broader assumptions for the long-term planning would also be very interesting.
Mm-hmm. Yes, for the planning, one of the main questions that we are faced today is what will be the future of the heat sector in our system, and what kind of flexibilities will we be able to use, because today we have only just the possibility to control renewable generators in real time. That's the situation today. So if, for example, with our 3 or 5% approach, we are able to reduce the power of generators instantaneously if we have a congestion situation. And we are not able to use flexibilities on the load side. That means even storages or flexibilities like heat pumps or electric vehicles. Today we are not able to rise, for example, their power instead of reduce the power of generators. And so what we are doing today is, of course, a lot of projects and demonstration projects. We can test all the systems to do this in the future, but in the operating system today, there are a lot of things that we are not allowed to, and there are a lot of things where we don't know how they develop in during the next years. And today we have the situation that, of course, behind, for example, dynamic curtailment, always the traditional grid reinforcement methods are the methods that are used today. But in the future, we have the target that we want more and more come into a world where we have where we use probabilistic methods for dimensioning our grids, and we want to get into the situation that we can actively use all the flexibilities in our system to prevent conventional grid reinforcements and all the costs that occur by this, because the heat sector and e-mobility are very good examples where you can see if we are not able to control them in this in the distribution systems in the future, and to control when, for example, the cars do their charging, or to control when the heat pumps are heating the buildings, then we will have a very, very high amount of grid reinforcements in the distribution systems that would get very, very expensive. And what concerning the question of, for example, dimensioning factors of all this new loads that we see in the grid, we have the situation where we have a lot of questions and only a few answers already today, because the question is what kind of loads will be controllable and what will be our role in the whole system, because the congestions in the distribution systems will be in the future not synchronous with the congestions in the transmission system, and that's always a big question. If there come control signals from the transmission system, because there has to be done, for example, feed-in management or the use of flexibility because there are congestions in the transmission system, then the question is, how will they correlate with the congestions that we will have in the distribution system in the future? And of course, that's a big challenge to synchronize the transmission level and the distribution level in the future, so that we don't get into a system where the transmission system could be optimized by using flexibility that is located in our distribution system, and we on the distribution level are not able to use this flexibility, and have and the result would be that we have to do very much grid reinforcements on the distribution level, and that would be very expensive. So the big question is how to optimize the overall system and to synchronize the system.
May I interrupt, because your question is the perfect bridge to our next speaker. And yeah, I see another question, but yeah, looking at the time, maybe very short. And then I think the next presentation will give us some answers on the question. But okay, Giuseppe, fast and quick, and Enno as well. Go raise your question.
Hello. Hello, can you hear me?
Yes.
Yeah.
Yes.
Okay, actually, my question is if the fact that DSOs cannot own or operate directly storage system, if this can have putting a limitation on the efficiency of DSOs. What is your feeling about this? Sorry for the noise.
Yeah, of course, because if we are not able to use this flexibility to reduce the amount of grid reinforcements on distribution level, that would be very expensive for the whole system, because the system length on low voltage level and medium voltage level, and the amount of cables and lines is of course much more higher than on transmission system level, and that's the big question. So I don't know if this is the right answer on your question. Maybe you could concretize your question a little bit.
I would like to stop it here, and I think the one idea of the workshop is as well to get you connected, and maybe there's a possibility to get in direct contact afterwards.
Of course.
Because I have to look at the time. So and maybe our next presenter could put light on these questions. And we don't have to spend more time on it. So Enno, thanks a lot for your very interesting presentation, and for the time you find for us. I'm very happy that you are joining us. And,
yeah, thank you.
Yeah, I'm happy to stay in contact with you. And now I want to present our the next presenter, who's Jonas Danzeisen, one of the founders from I have to say former startup Venus. Now you are not a startup anymore. I think you're hiring everybody from the market. So yeah. And he and his very innovative company works on solutions, on software solutions for handling the flexibilities in the not only the flexibilities to get all the yeah, to visualize what's going on in the low voltage or medium voltage or distribution grid, and how to use new tools to get the most use out of flexibility, which could be provided, and things like that. So I'm very, very happy that you find the time to present what you are doing. And yeah, I would like to hand over to you. Go on.
Perfect. Yeah, thanks, Holger, for the nice setup and best greetings from Germany, from near Frankfurt to northeast, south, and west in continental Europe. So I have to check how it works here. Perfect. To share my screen. If you do have any problems of hearing me or seeing our presentation, please just jump in. Yeah, give me a second. My name is Jonas Danzeisen. I'm a co-founder and CEO of Venios. Venios is a young, more or less young technology company based in Frankfurt. Actually, I'm in my home office due to the upcoming lockdown here in Germany. What are we doing? So what is the focus of Venios? Just to give you a few hard facts, a little bit of background information. I founded in 2012, owner controlled with some smaller stakes of investors in the company. We do have a strong focus on the energy sector, to make it a little bit more specific, on the local monopoly, on the infrastructure, on the grid side, actually providing our services to DSOs, to utilities. In Germany, Austria, we do have 100% a daughter company in Austria, Switzerland, Netherlands, Belgium, and in India, offering all the same platform. What the platform does, I will present in the next minutes. And as needed for a younger company, of course, we do have some recognition, some prizes. And at this point, the most interesting point from my perspective, we did win the FNN. It's something like a more or less a supporting organization to the regulator. And they decided to bring the grid transparency up and running with Venios. So we are really strong connected also to the German and European regulatory regime. Yeah, so basically, if you have any questions, please direct jump in. So what is the idea of what we do? And what are the partners we need for that? So Venios is 100% IT company, and we are just offering a platform service, and the platform service could be hosted on Microsoft Azure. The Microsoft Cloud service could be also hosted on private cloud services, of course, also on AWS. We do have a lot of partners in the measuring domain. We do have partners in the prognosis domain. We do have partners in analytics domain, and also, of course, partners in the SCADA domain. And so why do we need partners like that, and what is the focus of what we do? So coming from a top-down infrastructure, in Germany and now worldwide, the government decided to transform the energy sector from a top-down infrastructure to bottom-up infrastructure. And this means basically that you try to fill up a champagne pyramid, not from the top side. So we're trying to fill up a champagne pyramid from the lowest level to the medium level to the higher level. And seeing and having the picture of a champagne pyramid in mind makes it totally clear that the complexity of filling a champagne pyramid from top to down is much easier than filling it from the bottom to the top level, or filling it from several sides to bring an optimized or to have an optimized infrastructure. So on the one hand, what are the major drivers of the energy sector? We do have the smart meter integration in some countries in Europe. It's already fulfilled. In Germany, we are a little bit behind, or a little bit more behind. We have the distributed energy resources. We do have wind. We do have PV. We do have flexibilities allocated behind the meter at industry customers or in private households. We have the, as mentioned, the topic of sector coupling, and we have the electrification of the transporting sector. So the usage of the energy infrastructure increases massively in the variety of ways. On the one hand, on the other hand, the availability of data is pretty poor, and this is linked to the historic development. So if you have a top-down infrastructure, the point that consumption, the increase of consumption goes in a short period of time is pretty low. So there is so it's a relatively static environment. With the integration of renewables, with the integration of EV charging infrastructure and stuff like that, the speed of the changing speed increases massively. So there is not 10 years time to work on a scenario how to integrate renewables. It will or how to integrate charging infrastructure. It's needed to be in years or in maybe also several months. So we do have increase in flexibilities or in feed-in and load on the one hand. Based on that, the data needed to bring transparency to the infrastructure is massively increasing, and also the data quality coming from the DSOs to the TSOs is decreasing massively because of the flexibilities, because of local home optimization, self-consumption optimization, and topics like that. So to make a long story short, how does the infrastructure today look like? And these are screenshots of our Venia's energy platform. It's a real-time platform, and what we're doing is we're building up a real-time virtual twin of the existing infrastructure. We are storing all of the data of every asset in every grid element. So you do have 100% historical data setup, and if you know the status quo, if you know T0, and you know all the historic data based on or using models, you can generate with AI and other tools. You can have a forecasting for like a strategic forecasting, what will happen in 5-10 years in the infrastructure. But of course, it's a real-time operation platform. You can also see what will happen in the next minute or next hours. And this is crucial to do a real-time grid optimization, real-time grid management. And this and the amount of data, as also Dr. Wiebe mentioned, the amount of data is increasing massively, and there is no delta between using smart meter data or using a model, a load model for the household, because if you do a state estimation in the medium and low voltage domain, you have to take care about all the feed-in, you have to care about all the grid connection points, of all the households, all the industry users, all the assets they own, PV, combined heat and power, or whatever. So you need 100% real-time virtual twin of every cable cabinet, every substation, and everything that is existing in the infrastructure. And this is, if you compare it to the amount of data normally known to work on in the high and ultra high voltage domain, it's a massive increase. Based on that, if you have a real-time virtual twin and you have a prognosis solution based on that, or have a prognosis algorithms based on that, you see where problems could pop up. You see if you have a reactive power problem, if you have a capacity problem in the infrastructure, if you have a capacity problem in the substation, in the cable, wherever. Also, if you combine it to heating infrastructure, you see where problems on the sector coupling interfaces pop up. If you take a look on what I presented you in here. These are customer installations in continental Europe. Yeah, mostly continental Europe, and they are used for operative. They're used today for operative grid management, grid control today. So it's not in 5 years, in 10 years, in 20 years. It's today up and running, and we use our solution, or our solution is used, not we, our customers use our solution for real-time capacity management linked to the problems of charging infrastructure. There are markets that have a huge increase of charging infrastructure, and of course also e-cars that are charged in the charging infrastructure, and this leads directly to capacity problems. There are two ways you could control the charging infrastructure on the one hand, or you could increase the capacity of the infrastructure. Increase the capacity means basically digging holes and throwing hardware inside. This is, of course, if you have a small cable to a big wind park, real-time monitoring is nice, but this will not increase the capacity. But if you have normally, it's not black or white, it's gray. And if you're in a gray situation, a real-time status quo and the combination of intelligent charging, also just basically a hard control of the charging infrastructure, or hard control of heating infrastructure, and all the flexibilities that are allocated in the grid, is the way for an optimized usage of the infrastructure. So basically, it's the question CapEx or OpEx, or what asset could help me for an optimized management of my infrastructure. Of course, this is a complex topic, and so the question is, how do we do it? So what is needed to, and what is the time scale for integration of a solution like that, and does it work, does it run, does it give me the value that I need? So beginning of this really strategic and really one of the key slides in this presentation. So we start at the bottom line. So what is existing at the normal DSO? You have some measurements in substation, cable cabinets, whatever. There's normally a SCADA solution from PSI, EDS, Kistes, Schneider Electric, GE, whatever. We have master data. There is a geo-information system, and the geo-information system is a really good example to show how our solution interacts with the status quo infrastructure. So if you do a real-time ample phase management of the grid, it's really nice to know, or it's needed to know, to see there is a cable in the street, but it's not 100% important to know if the cable is right under the pavement, left under the pavement, or in the middle of the street. For solving a hardware problem, to dig a hole, it's really important to know where the cable is. But for ample phase real-time grid management optimization, or grid optimization, it's not so important. So our solution basically normally is slave to the geo-information system. The geo-information system gives the information where the asset is. The asset management gives normally the information what is the kind of the asset, the diameter, hopefully the age, and more information. Sometimes there is also a network information solution integrated that gives information about the electrical status of the infrastructure, and of course EDM data, smart meter data, weather information, socioeconomic data, and we're using these third-party data like weather prognosis, of course, in socioeconomic data, because even if you have 100%, grid equipped with smart meter data, normally you have, if you come from a smart meter side, you have a 15 minutes time resolution, and the 15 minutes is for a grid, from a grid management perspective, it's basically not enough. So we're using socioeconomic data for private households for refining our prognosis, depending on how many people live in the household, how big is the house, and stuff like that. Also used for industry customers, and so basically to shorten this up a little, we do have a hybrid approach going from 100% modeled to 110% measured approach. So we can start with nearly no data, from the existing infrastructure, and then going integrating the data from the SCADA solution, integrating the smart meter data, integrating data out of the cable cabinets, and this is then growing and growing and growing. And if you start to integrate measured information, you have a decrease of failure, of course, because having a measured information is always better than having a model. So this is the hybrid approach we are using. So based on that, we get all the data of all the existing solutions, and based on that, we're building a hybrid digital virtual twin of the existing medium and low voltage infrastructure. And this needed to be, of course, absolutely scalable. Scalable and fast and easy to roll out. Based on that, you can do monitoring like status quo. You can do forecasting as described. You can have a control like having direct access to the infrastructure. We do this in several markets. You can do planning, of course, because planning is really easy. If you do a real-time virtual, if you have a real-time virtual twin, planning is totally easy to do, because manipulating the virtual twin is planning basically. And of course, you can do analytics. We're existing, so we have our platform actually at the most customers in continental Europe based on the energy sector. We just integrated fiber optics, and we will expand in next year to gas and water. This is up and running at customers, and then we will present it commercially in the market. To speed a little bit up, these are solutions. This is our logo graveyard, we call it. These are solutions we have interfaces to. Some companies know that we have an interface to their solution, some don't. But these are solutions where we basically can do memory dump into our solution. In ideal, we do have a high performance interface, bidirectional interface solution. Having normation, or having something like an enterprise service bus or a norming layer over these existing infrastructure, this offers for partners a really nice perspective for putting their solution to put their solution or connect their solution to the Venia solution, because we do have known data quality, we do have existing interfaces. So for partners like IBM, it's super fast and super easy to integrate a workforce management or asset agent model on an existing infrastructure with a known interface, with a known data quality. So the risk of integration of a new IT solution decreases massively. And just to give you a feeling about, so up to 2,000 substations or maybe 3,000 substations, we do need less than 10 days for a rollout of our solution up and running, and then normally some fine tuning on the solution, and so our solution normally is up and running within less than 3 months at the customer's side. It's totally scalable, and the platform is absolutely the same if you go from the Netherlands to Germany to Switzerland to Austria, or if you go to India. So we are able to take knowledge, to take our experience in flexibility management we have in India, because the less regulation, more freedom for the owner of the monopoly, so you can do basically everything. It's super easy to bring technology and to test technology, even if you don't have the regulatory framework in continental Europe. Outside of the European Union, test it there, and then bring it back to the market you're in. And from this perspective, I just jump into this directly. We have seen the VDE offers has shown a step or a level perspective on the levels of grid operation management. And so we have the old world, like level 0 going up to level 5, and this is connected to the levels of autonomous driving. And level 5 autonomous driving is basically, as a DSO, there is no work to do it, so it's fully automatically. And actually, the roadmap shows that level 4 automation should be integrated within the end of this decade. And if you want to see how it it will be in the end of this decade. If you want to see what level 4 automation is basically how it looks like, this is possible today, and this is possible today also. If you want to travel to Switzerland, really nice place. Zurich, we do have a part of the grid of the Elektrizitätswerke Zurich, where we have a highly integrated, highly automated infrastructure. And also, if you want to stay in Germany, we do have a project in Saarlouis, and this is pretty interesting because in Saarlouis we do have also 100% smart meter rollout. So every smart meter is connected to dark fiber. We do have every grid asset is connected to dark fiber, and we do have a real-time state estimation based on that prognosis, of course. And the prognosis is used voltage. Prognosis at this point, and this prognosis is used for a real-time access to power-to-heat installations to optimize voltage problems within the low voltage domain, and this is completely automatically up and running. So it's not a demo. It's a little special situation because there is no regulatory framework for that in Germany, but it's up and running and it's working. So having the future to the 2030 future now, you're happy to visit our customers and see what's up and running and what's working in the market. We know that solutions like that are pretty interesting also for as a service solution. So we do have partners that do grid control as a service in Germany, and we offer our solution within this package. And we know that, or we see that, especially if you go to Nordics or if you go to some regions, it's needed to have the data not in a public cloud. It's needed to have the data behind the fence on the ground of the utility. Of course, our solution is fully practically on basically every cloud infra or every IT infrastructure. Behind the fence in a private cloud, and we were the first worldwide to offer our solution in a private cloud environment with Microsoft Azure. That's how it looks, and I'm out. Next picture is my face with less gray hair, so I go back to this.
I think this is the most interesting part, the energy platform and the flexibility platform. We talked before about that. Maybe you just can take a minute to describe how your flexibility market platform work and especially without regulatory framework.
So we do see an increase of the complexity in the usage of flexibility. So from a flexibility perspective, like a PV or a battery, whatever, the flexibility does not care about what man-made market is the problem why the flexibility is used. So if you take a flexibility for offering the flexibility in redispatch 1.0 or 2.0, if you use the flexibility to solve a reactive power problem, if you use the flexibility to solve a grid capacity problem or a voltage problem, the flexibility does not care. But if you want to have access out of the monopoly to a flexibility, you have something like, or you need something like a multi-market optimization. Also, of course, the flexibility is used in self-consumption, and the flexibility is brought to a market. So on the one hand, you have the problem to solve problems, physical problems, in the infrastructure, and on the other hand, there's a variety of ways to get money out of the flexibility. And we do have a project in Austria where we do have a heating grid and an electricity grid, and we are using also sector, or we are using over the sector boundaries away, a holistic optimization to the market for using flexibilities within the grid, flexibilities behind the meter, customer flexibilities for an optimized cash position, basically. And so if you want to, or if you're using flexibilities at the customer side, linked to the regulatory framework that is possible in the country you are, we see using a flexibility basically first step as a technical problem, and second step you have to put a market regime on that, and the market regime then needed to be linked to the regulatory framework, and it needed to be profitable for the owner of the flexibility. And at that point, yeah. So
yeah, thanks a lot, Jonas. This was a very, very interesting presentation, and I think for a lot of us it had been a vision of the future before you told us it's already running solutions like that.
You can buy it. Return of investment is less than 1 year if you have a not so optimized DSO.
I don't have the grid and I don't have the money, but maybe somebody out of the audience. But now we have some time left for questions. Please raise your hands and try to be short and precise. Yeah, go on with your questions. Nobody has any questions. This was too much.
So if you you will get the presentation as a PDF from the organization. If you have any questions, if you want to have a live demo, this was too short for also integrating a live demo. So we do have only a customer installation, so we could directly jump into a customer installation and see how automatical flexibility management, how automatical management of charging infrastructure, batteries, combined heat and power, whatever it is, and show the impact on the grid, and show how in your regime could be a CapEx and OpEx optimized way for grid management. Because the most important point is the electricity grid, if you focus on that, is such an important critical infrastructure and such a expensive critical infrastructure. So we should do, from a society point, we should do everything for an optimized management of this infrastructure. And the decision to integrate renewables is a political decision, and the decision how the market or how the monopoly reacts on that, this is a political decision. From this point, the tools are up and running. If you have any questions or if you need extended details on what we do and how would be an installation in the country where you come from, please don't hesitate to contact me. So we are working on bringing our solution to North America. Maybe some partners from outside of Europe within this call. We will have in the next year, we do have our first installations in North America. We do have a nice project also up and running, starting in Australia, and we are checking the market out in South America. So from this perspective, it's a global platform, it's a global community of DSOs, and it's totally nice to see how also the information flow and the communication between our customers internationally work. So bringing knowledge from India to Europe, because the regulatory framework is much freer in India than it is in Germany. This brings really also an impact on the regulatory discussion. So be part of the network and optimize your infrastructure, CapEx and OpEx optimize. That's
okay. There's one question coming from Giuseppe again.
Yeah.
Yes. My question is on the concept of digital twin. You have mentioned it in your presentation. Can you be more precise? In sense, is a digital twin a perfect, say, replica of the real distribution network, or it's just, say, built from scratch? Can you be more precise on this? Thank you.
So we do have. So if you do or if you want to do real-time grid management, you need so what is a perfect copy of the reality? So of course it's a reduced model of the reality, because we don't need to know the color of the box around the substation. So it's no need to know the color of the cable in the ground. But the physical factors needed for a real-time state estimation, of course, they're 100% included. So it's everything you need for real-time grid operation, and everything you need to give 100% description of what is going on in the infrastructure is inside, and even a little bit more. And focus on that is grid operation, real-time grid operation. It's not an asset management. If you want to have an asset management that also includes some information, we do have partners like IBM or SPI or whatever to offer an asset management. So the focus on Venios and what we're doing is real-time grid operation as an existing solution, in addition to your SCADA solution that is normally already implemented since years or decades in your infrastructure. So if you have any details more, if you could just send me an email, and I will hand it over to my colleagues from the technical department if detailed information was not presented in this presentation.
Thanks a lot, Jonas. And yeah, I think there are a lot of questions will come later on, because this was very impressive what you are doing, and how fast you are going on, and how fast you are able to automatize a grid. Thank you very much. And,
thanks for the presentation.
Yeah, I think we stay in contact. And now there was a question coming up, how to raise the hand. If you go to the participants button, or you pull on the participants list down, there there's a possibility to raise a hand and to put it down again. So thank you, Jonas. And now I'm very happy to present our next lecturer. And I'm very happy that I was able to find somebody out of Germany who was willing to speak. It was very hard work, but in the end I find I'm very proud to get in contact with Anne van der Molen. He is working for a lot of different companies. Today he's speaking for, I hope I pronounce this well, for head. I have to look it up. Net Be Here, Netherlands, which is, as I understand, association between TSOs, DSOs, and customers in Netherlands. And I'm very happy to pass over to you now, Anne, and I think we got the next presentation. And yeah, please go on.
Thank you, Mr. Leu. Can everybody hear me? Can you hear me, Mr. Leu?
Yes, I can hear you very well.
Yes, okay, good. Thank you. Yeah, around 2 weeks ago, Mr. Leu and Mr. Marco from ETSO, they approached me with the question if I would be interested to share a presentation on how we do infrastructure planning towards the Paris Climate Agreement. And well, I took the invitation. I'm happy to show you some of the insights of the approach that we follow here in the Netherlands regarding that. Yeah, my name is Anne van der Molen. I work for Stedin. It's a DSO, it's a Dutch DSO. And as part of that job, I am also representative in EDSO. And I'm member of the Energy Transition Core Team of our DSO-TSO National Association, Net Beheer Nederland. from that position, I'm doing the presentation today. So the question was, how do we do infrastructure planning in the Netherlands, and how do we approach that? The context of that is that as part of the national implementation plan for the Paris Climate Agreement, it was decided that the two TSOs, the gas TSO and the electricity TSO, so TenneT and GasUnie, they got the mandate to deliver an infrastructure outlook for 2030 and 2050. TenneT and GasUnie and the joint DSOs, they decided to organize this as a joint project, so a joint way of working, and I will later on explain why that was decided. And then project II3050, so II stands for Integrated Infrastructure, 30 stands for 2030 and 50 to 2050. So the project II3050 was formed, and that project that works closely together with governments, with industry, and with various associations to on infrastructure planning related topics. And in this presentation, I will elaborate on how we organize this, so how we organize the way of working, and also share with you some of the results of the II3050 project. And if understood correctly, we do questions after the presentation, right? Or can we also do, yeah?
Right. If something is very urgent to understand things right, people can raise their hand, but if possible, we will do it later on, so don't interrupt you.
Yeah. Yeah. So let me start with the Paris Climate Agreement. In the Netherlands, that was translated into several topics, tables as we call them. You will see them here. So it's related to electricity, industry, society, mobility, agriculture, and built environment. And you could say that electricity then deals with electricity supply related topics. So RES integration, sustainable production is part of the electricity table, for instance, whereas the other tables are more related to demand. So the electrification of industry, for instance, is part of the industry table, and the use of sustainable mobility or electrical or hydrogen-related mobility, for instance, is part of the demand, it's part of the mobility table. And what you see directly is that they are related. So a change in the industry table or decision in the industry table related to the energy source has its impact on electricity. So there are various dependencies between those tables, sector couplings as you could call them, and that shows that you need to, if it concerns infrastructure planning, you should do that through an integrated approach. Now, energy infrastructure is the part that connects all those tables from an infrastructure point of view. And the climate agreement states and has targets on CO2 reduction and on changes of supply and demand of electricity. But that will have a strong effect on infrastructure, because the infrastructure needs to work, and needs to work not only under normal conditions, but also under more extreme conditions. So for instance, in days when you have a high demand or a low supply, like a winter day or a hard winter, a winter week, or vice versa, the sunny summer day with lots of wind and where everybody's on the beach and there's not a lot of demand. So you could have a dunkelflout, you can have all sorts of peaks, and the system has to work. And that was one of the design targets for the project, to calculate against all those extreme conditions. Straight from the beginning, it was decided to do an integrated approach. The project is called Integrated Energy Infrastructure for a reason. And that is because there is a lot of interdependencies. I just mentioned the interdependency between industry and electricity. Well, there's of course many more interdependencies. It's dependencies between electricity, gas, and hydrogen. There's dependencies between the national grids and the distribution grids. There's dependencies between industry and mobility. So there's a lot of dependencies, and we need to take those dependencies into impact. We also need to be able to give insights to decision makers, so governments, but also the tables, on impact of the decisions that they take. There is some national programs there. So government has some national programs, national planning programs. Of course, there's infrastructure planning, so the 10-year network development plan, for instance, that TSOs have. There's all sorts of national programs, and it was decided that the integrated infrastructure should be a building block or a input source to those national programs. And you will find a few of those listed here. Organizational-wise, the decision was taken that although the project was organized with the DSOs, we should have a core team of the program was organized with the association. So it should have a core team of the DSO, TSOs, and national government. So that's the core team. And that's also where we do the connection with the national programs. And we should also have a reference group. And the reference group is the stakeholders from the various tables. So the industry, agriculture, energy companies also, and the various associations. And then there's a third tier, that is the other stakeholders. And those three, particularly the core team, should then also be the funnel towards the decision makers, so the politicians, and also the national government on the progress tracking of the implementation of the Paris Climate Agreement. So jointly, we decided on a phased approach, which consists of 3 phases. So the project, as you can see here, started in 2019. And in 2019, we also directly started with phase 1 of the 3. And roughly stating, we said that the project should start with energy scenarios. We should, if we do infrastructure planning, work with a common ground, so common set of energy scenarios. Now, Holland being a densely populated country means that we have planned our scarce square meters, square kilometers. So spatial impact and spatial planning is an important aspect in, I guess, every country, but also here. So it was decided that that would be part of the planning process. Also, in the climate agreement, in the implementation plan of the climate agreement, it was decided to work and define energy regions. So Holland is subdivided into 30 regions, and each region does its own energy planning. As part of alignment of those planning, it was stated that those energy plannings of those 30 regions should start with a common set of energy scenarios. Now I'll go back into and give you some background on the energy scenarios in a few minutes. Now, once you have the common energy scenarios and a common data set of energy planning procedures or forecasts, then you can move into the phase that's called network impact. Actually, that's the phase where we are in today. So we are able to calculate the impact on various network levels, on various fuel sources of the scenarios that we have towards 2030 and 2050. And once you did that, then you will enter into phase 3. You can define and you can outline the infrastructure development plans. Now, phase 1, or before we go into phase 1, so the phases are subdivided into phases. This perhaps gives you a bit more visibility on what we do. So we start with energy scenarios. Then we have developed and aligning a tool to be able to do energy system calculations. Then we are able to do and subdivide them into regions. Then we can do grid modeling and grid calculations. And then we can do infrastructure analysis. And it was explicitly stated that we should do energy calculations before grid calculations. And one of the reasons, it's very practical, is that the Paris Climate Agreement deals with energy and not with network infrastructure. So a lot of the topics are energy related. So we should have insights and give feedback and visibility on those energy questions first. And that also gives time for regionalization. And what you will also see is that flexibility modeling is also quite early in the process. So whether it is conversion, energy storage, or exchange, so the international interconnects, Those are really early, listed early in the process, so we can do the impacts on those aspects directly and early on in the procedure. In the first step, we designed the energy scenarios. And while saying this, it's worth to mention that they are really meant as for potential possible implementations of the fuel mix in 2050. And it's not that one of the four should be the most realistic ones. No, they should give the most, they should differ from each other, so we can investigate the energy system from various topics. Now, the parameters that we designed energy scenarios on, you can see here. They are in Dutch. I will translate them. It's power and lighting. That's typically electricity applications. It's low temperature heat. So it's mainly how we heat our houses. And nowadays in Holland, we do that through natural gas. We have heating networks. So one of the questions there is how we will deal with natural gas. Where will we do hydrogen here, or will we do heat networks? The other one, third dimension, is high temperature and feedstock industry. Today we have quite a substantial natural gas economy, and natural gas also gives components for the petrochemical and also the chemical industry. So if you, like our plan today is to minimize natural gas or reduce on natural gas, that will directly have an influence on infrastructure in industry, in industry development. So that's why it's listed here. The parameter 4 and 5 deal with public transportation. One is public transportation for cars and trucks. They are subdivided. Then it's renewable growth, DER growth, and finally it's how is modeling and choices around conversion and storage. You could say, for instance, that there is a choice to be made whether we want to invest and want to have lots of battery-related storages in households, for instance, or whether we want to use centralized caverns to store natural gas or methane or hydrogen, for instance. At the right-hand side, you will see a few extra parameters that were added, not in the Paris Climate Agreement, is how we do aviation and kerosene use. We did introduce them as extra parameters in the data set to be able to say something about it. We have a substantial port in the Netherlands, it's the port of Rotterdam, so also a few topics related to how we deal with oil use for shipping is introduced there. And we introduced several stress scenarios related to weather. And for all of those four scenarios, we define data sets. Here you will see them. Those are the four scenarios that we have. So from left to right, it's determined. So one is the scenarios, the left-hand side is where we do regional control. So the regions in the Netherlands are able to define their own energy strategy. So a lot of the incentives are related to local incentives. Number two is national influence. So we decide as a member state for ourselves how we deal and organize our energy system. Then there is a scenario related to European influence, mainly around CO2. And one is that there is control and a lot of traffic ongoing on the international market. This, for instance, the scenario where we would have massive imports of, for instance, hydrogen from Australia or from Sub-Sahara, or we would have feedstock from other parts of the world into the Netherlands. So once we had those scenarios, we could start giving feedback on some national policy issues related to implementation. Here's a few examples of questions that were on the table in the implementation team for the Paris Climate Agreement. One is the question on how industry and electricity are related, for instance, to each other. Industry is subject to heavy international competition. So it is a big difference whether the industry is proactive and takes sustainability measures soon or late. And the question was, can we calculate the impact of a fast or a later incentive and change at industry. Another one is related to the fuel mix. How big is the impact if we steer on loads of DERs, so solar and wind, or what will be the impact if we will significantly reduce on methane? So the fuel mix in combination with fuel efficiency, and impact of that is a second topic. Third is the spatial planning. You could say that, for instance, that if we move towards solar, we will have a lot of space. We will need to reserve that for solar farms and solar panels. Same for the North Sea. If we would go for wind, then we would have a lot of impact and need to dedicate routes that are nowadays dedicated to sea transport would need to be dedicated to wind farms. So the impact on spatial planning is an example. One is systems integration or sector coupling. How can we estimate and give feedback on what the pros and cons would be if we would do a hydrogen infrastructure and a hydrogen economy? And last but not least, it's related to energy storage. Nowadays we have methane caverns in the north of the Netherlands where we can save up natural gas for cold winter days. And can we do that also with hydrogen? And what would the impact be of the infrastructure and the fuel choices in the use of those caverns? Now, so far so good. So we had scenarios. We could fuel and support on scenario-related topics. Then we will go a bit into the network impact. Like I said, that is a phase that's ongoing right now. So it's some temporary intermediate results, a sneak preview, so to say. While saying that, shortly off topic, this information set that I'm showing you now is deliberately, or is quite well known in the Netherlands. So it is shown to Parliament, members of Parliament, it's shown to government representatives, it's shown to industry representatives, with the sole purpose of getting a common base and a common understanding of the scenarios as well as the topics. So the information you are seeing here is in the Netherlands at least open information. It is one of the first times that we're showing it outside the Netherlands, so let's say you're having a sort of a premiere, but it is open information. So when you're looking into 5 minutes left, then I'm right on time. That's good. So if you start mapping the energy scenarios into the infrastructure scenarios, you directly come into the question, how do we deal with flexibility? So you need to factor in flexibility, and that is exactly what we did. And with flexibility, we mean flexibility within an electricity system, within a hydrogen system, but also sector couplings, power to gas, gas to power, and so forth. So because flexibility is so important, we decided that there was one reason why we did energy system calculations before grid calculations. But we got there, we are in the grid calculations. So with the common data set, the hourly values between now and 2050 is available as a data set, and that could be used and is used by the TSOs and DSOs. And this is the result, for instance, that we did on system analysis for electricity. We are able to prognose or do scenario planning on both the demand and supply of electricity, for instance, in the 4 scenarios. We're also able to do that in hydrogen and methane. And we are able to draw some conclusions here, for instance. And what we see is that in all scenarios, for instance, we will need gas storage, both methane and hydrogen. In the electricity system, we can calculate the impact on the balancing markets and the requirements and the need for balancing power, for instance, towards 2050. We are also able to define flexibility a bit deeper, so we're able to see how much battery we will be needing, but also how many seasonal storage we will need in order to facilitate the system in all extreme weather conditions. Now, exactly the network impact, these 3 examples, we are able, and that's the phase where we're in right now, we're able to map that on our TSO network. also in the interconnect, but also in our national TSO network, TANET network, we're able to identify the time and also the amount of network overload, and able to determine in the various scenarios where we should have capacity and will have capacity bottlenecks. And of course, like the disclaimer said, it all strongly depends on the scenarios, and they are not indicated to do the real network the investment calculations. They are able to show the impact of scenario choices on infrastructure. So we're able to do the same for our current methane backbone. We have a substantial methane network, gas network. One of the options here is to split that network into a hydrogen backbone and a methane backbone. And we are able to use the scenarios to calculate the feasibility of those two options. And last but not least, we can also do the same for the DSO networks. And we can define within DSO networks where we will have capacity shortages, when, how big they will be, both for the electricity and for the gas networks, and in the various scenarios. Now, this is the phase that we will enter, as you can see, from 2021. Then we're able to go into the phase with the various stakeholders on the impact of the choices they make on infrastructure investment need, but also on spatial impact. That's it. Thank you.
Yeah, thank you very much, Mr. van der Moel. This was quite impressive, and thank you for being so open, showing us the first time how in the Netherlands planning goes on, and what kind of information you provide to your government and to the people. I think this is for me, it was very impressive to see how inclusive the network planning in the Netherlands going on, so that you involve different stakeholder groups and working close together between TSO and DSO and other involved parties. I think this is a very, very good approach, and we should should use this as best practice example. I think other countries can learn a lot of about that. There's already one hand raised by Innovium, and I would like to go on with the question and answer. Innovium, please go on.
Yes. Yeah, thank you, Anne, for this very interesting insights. I have a question concerning your government, and in Germany we heard that the Netherlands government plans to integrate 10 new nuclear power plants into the system. And my question is, do you already calculate with them? Are you taking them into the account already into your network planning? And what effects would have these power plants have on the system?
The good thing about that is true. There are voices that state that we should invest in nuclear. And the good thing about the project II-3050 is that we have the tools to calculate the impact of a nuclear scenario on industry, but also on infrastructure. So it is included as one of the potential fuel scenarios in the project. So the outcome of phase 1, for instance, is the fuel mix that we will have in the Netherlands, subdivided into electricity, gas, and so forth. And also behind that is an identification of the sources that we will have to generate electricity, for instance, or to generate hydrogen. So the nuclear is added as one of the one of the 4 scenarios. Actually, it's the 5th scenario, and used in calculations, both from financial perspective, spatial perspective, and there it can be integrated into the project approach. Your statement that the government is planning is maybe should give it a bit context. And so the context is that a few political parties are saying that we should invest in nuclear. It's not a decision taken to invest into nuclear. The approach now and the stages we're in now is to handle that national discussion, so to speak.
Okay, thank you.
If there are no other questions coming up, I don't see any hand. My question, maybe to go on with this topic, your modeling should be easy, be able to show how a network could work with higher shares of renewables. So you could influence the political debate. Will you do that, or it's more hidden information?
Well, the whole idea of working together is that we are as transparent as possible. And in the end, the network operators, they are a publicly owned industry. So we are regulated, we are government owned. And also the approach is that if there's any debate, we should be in the role that we give inside information and give data sets that the decision makers can take decisions on. So we do that through an open debate, through the core team, and also to the stakeholder teams, for instance. We try to do that as transparently as possible.
Sounds great. And another question more close to the topic of this event. Do your modeling show an effect of modern modern-driven DSO networks and high use of flexibility to the upper voltage level or to the transmission grid, and how strong is it?
Yeah, we're able to make that visible. It went a bit fast, but perhaps you can recall from the impact analysis on the electricity system, for instance, you saw a big difference between supply and demand. So that you can only handle that through either balancing or through other sorts of flexibility. So from that given on, you can analyze how much flexibility you need. What we are also seeing is you can also look at that from different time angles. So we see the intermediate need for balancing. You can do the same calculation for seasonal flexibility. So the difference between a summer where you have an excess of production and a winter where you have an excess of demand. And we can also find out how much seasonal storage we will be needing. While said that, this is an infrastructure planning thing. So what this exercise does not do is market forecast or market planning. So if you have an unbalance, for instance, or a seasonal need, it really shows how much we will need in the system. It does not indicate how much flexibility we have available and whether that is enough or what impact that will have in the market.
Mm-hmm. So this is quite interesting. So if there are no other questions coming up, I thank you again. I think it was very, very impressive insight, and I'm very proud that you let us look so deeply into the network planning and the energy system planning of the Netherlands. I think this is very useful for a lot of participants. And we have a little echo at the moment from across Europe. So there were registrations from Latvia to Spain and from Ireland to Greece. And I think a lot of other countries should have a deeper look into what's going on in the Netherlands. Thank you very much for that. And and I will pass to my colleague Antina. She will
ask a question?
Add some words.
Okay, once there is a question actually. So I think Thomas, have your question.
Yes, please. Thanks.
And turn on your video so that we can see you.
Pardon, but my video is actually not working right now.
Darn. Okay.
I have got the question with regard to Anna's presentation. Thanks a lot for your insights. What about how fast could you handle a decision impact on your scenarios? For example, this decision upon going into the direction of more nuclear energy. How fast can you analyze such an impact on your scenarios, like a sensitivity analysis?
So if you, that was a question to me, I guess.
Yes, of course.
Yeah. If you would recall one of the first slides was the stakeholder map, and what you see here is that the sensitivity analysis is also a matter of sharing information and explaining and sharing insights to the various stakeholders. So in this particular case, the requests came from the national government. They would like to have the scenario calculated. And then the project did the math. And then the presentation of the results was also handled by national government. And the reason was that it should be communicated in a way that is as neutral as possible. So although the technical analysis can be done quite quickly, in the end, in the front-hand side, you would need to get the information up and running, available, and in the back-end side, you would need to organize communications. So what you will typically see is that although the technical analysis can be done quite quickly, and the overall process will take substantial time.
Okay.
And then again, I would also like to de-emphasize the nuclear thing a bit. I think that's going on in many countries. The question is, how do we handle our fuel mix? So the topics in the Netherlands are mainly is hydrogen. How do we deal and how do we grow hydrogen? It is sustainable energy. How do we grow solar? It's around natural gas. How do we replace natural gas as a heating source for our houses with another heating source? And those contexts, yes, there is also somebody who brought in something about nuclear. But it is one of the elements in the discussion around the energy planning and the climate agreement planning. And it should also be seen in that context.
Yes, thanks, Mr. van der Molen, for this clarification. And yeah, again, for very interesting insights. Now, I think if there are any more questions, I will pass over to Antina again.
Yes, that's for logistics. We want you to join our breakout groups. I have put in the numbers of the different group names in the chat once more. Please rename yourselves by adding to your name the number. How do you do this? You go with the cursor to your name in the participant list. If you don't see the participant list, it's on the bottom where you have those little man icons. Click on this, go to your name, click on more, click on rename, and put the figure 1, 2, or 3 next to your name. We will share during the break, which comes now, the screen, so that you can see these figures of the different groups. Please add the figure to your name so that we know where to put you to for the breakout groups. Thank you. And how long will we do the break?
I think it was very dense. At least 10 minutes. I think I would prefer 15 minutes, so that we are fresh for the work and the working groups.
Which means back here at 23 past 11.
Yeah. So see you after the break, fresh and ready for work hard in the working groups.
Hello. If it's possible, please put me in group 2.
So, welcome back. Everybody use this break well to get prepared for the working groups. We have 3 different working groups and less people than expected, so we are able to work very efficient in smaller groups. The groups will be moderated. The first group by my own, the second group by Dr. Eva Schmidt. Thank you very much for doing that. And the third group by Franziska Flaxbart. Thank you as well. And I hope everybody find it the right group. The rules are Chatham House rules, so we will record the sessions, but just to make it easier for us to extract topics which are coming up and where we might decide to look deeper into. If a group has nothing to discuss longer than the time runs, we'll come back to the main room, and I would like to use the remaining time after the breakout sessions to let us know which group has which results, and to discuss them once more in the bigger group, so that we really get feedback from all sides and to share the knowledge we could generate. So we will start the breakout groups now. I wish you a very constructive discussions, and I'm very curious about the results we will generate in the next 40 minutes. So let's start the breakout groups.
I need everyone who's needed to make co-hosts before I send you out to the groups. So give me a second. Where's my co-hosts? So now everyone should be co-hosts, and there we go.
So yeah, welcome to this very small breakout group. We are just 3
Olivier, if you are there and listening, I'll be happy to put you into one of the breakout groups, but I don't know which one.
So we lost some people, but I think we can go on with our with the last part of the event today. And now we want to present the results of our groups and give the bigger audience the possibility to ask questions or to discuss things with the others. Maybe I should start. And we're a very small group with just 3 people in it. And we decide that we are not able to discuss the question, which was the topic of our group, to define what are the most important data and values that should be used to give to a European energy system model to show the impact of DSO grids. And we decide, or we find out that we have an overlap in our knowledge and expertise in the heating sector, and we figured out that the question how we will deliver heat in the future is very important to get an answer of how high the energy demand is within the DSO grid and how DSO grid could work, which amount of flexibilities do we have. So we really have to look into the heat sector to get an answer of the behavior of the distribution grid. And we figured out that it would be very helpful to have something like a heat map where demand is visible as well as maybe heat sources. And we figured out this is a very local question. So you have in different areas very different possibilities to produce heat, depending on the ground, depending on rivers or lakes, depending on biomass, as well as on the density of renewables, especially of PV, because we expect that we will have in the future very high PV peaks, which could be used to produce and store heat in a way. We also discussed the question of usage of hydrogen in private households, and I shared a study from Fraunhofer IEE, which figured out that hydrogen has no positive impact on a household level if you take into account the energy demand, the demand on infrastructure, and alternative production of heat. So the heat pumps are much more efficient and much more have a higher efficiency in respect to climate change. Yeah, we short discussed the question of seasonal heat storages, like they're used in Denmark. And we figured out that the question of where it is sensible to build a district heating system depends on the one hand on the population density, on the other hand as well on the efficiency of buildings. So if you have a area with newer houses with high efficient isolations, you will need such lower amounts of heat that the district heating system is not economically feasible. Yeah, and of course we figured out that the heat system as well has a big impact on the DSO grid in respect on flexibility. Yeah, this is maybe a conclusion. Any questions on that? So if there's no question, I would like to pass over to Eva.
Yes. Can I share my screen? I'll try quickly.
You are co-host. You should be able to share
yes.
screen.
Sorry, this is here. Okay. Yes, you see that now, right? Okay, so how can distribution networks be clustered? Was the question in our breakout session. We had the claim that computing power relieves the need for clustering or even removes the need for clustering, because you could just simply, in a world with very high computing power, just use the real data for everything. We then realized that it really depends on the perspective you have. So the overarching take from the discussion is that the solution for clustering really depends on the question that is asked, so the purpose as well as the country that is modeled. And basically it's simulation versus optimization and top-down versus bottom-up. So there is modeling suites and models these days where you can have very strong bottom-up perspective, use real data and basically simulate, but also optimize. But over the discussion, it became clear that for some application like a European-wide, sector-wide optimization, as the TYNDP, also in combination with DSO perspective, needs to do in a manageable time frame. So a also conceptual problem that needs to be tackled within the half a year of a project lifetime, for example, then actually there is a need for clustering. But it took us quite a while to identify this and get on the same page of what is actually done. So and then we did unfortunately not have so much time to actually speak about how this could be done. But I think the key word here is interface optimization, that you spend quite some thought on which data needs to be handed over between, for example, different grid levels, or also between sectors and also between countries. And that's the route you want to go. We also had a very different perspective voiced about local optimization and artificial intelligence application for local markets. Also a way to conceive clustering. But it's a very different purpose, I would say, or a different question that's asked to the model, this type of perspective, than for the TYNDP application, for example. So I think the main takeaway is if talking about clustering, do spend a lot of time on asking what is your question that you want to find out with the model, because that's the that kind of lays the route to your answer already. And I think many people have a different understanding of what a cluster is, and since clustering is about reducing information, it's crucial on what perspective you have. If you kind of sit in the bottom up sphere, then you do look up for the clustering. If you sit top down, you look down for the clustering. And if you don't make this explicit, then basically you will speak about so different animals that you can speak for 5 hours, but you don't speak about the same thing. As a last word, there in our group there were there was two academic applications, so people that actually work academically on the issue, and NSOE and DSO associations are actually need to work on the issue. So and also company perspectives that have problems related to this question. So there is also a need to solve this question for specific applications. And there's also data sets available, also the possibility to work with an a data set that's made anonymous, because data availability is always a question, obviously, particularly if you talk about bottom-up optimization, because then you need a lot of data from very small entities, which is not always available, but you could also use synthetic data for that. And I will stop at this. Thank you.
Yes, thank you very much, Eva. Yeah, I think this is a very helpful findings, and I think your group was very well mixed, so I could imagine it was a fruitful discussion, and we will think about how we could make this question maybe more specific for one of the next workshops. So thank you very much, and I would like to pass over to Franzi to give us insight on what was discussed in her group.
Okay, thank you, Holger. We were a very small group to discuss the third breakout session, where we had the question what the distribution network could ideally contribute to relieve the transmission grid. First of all, it was a little bit hard to start the discussion because we missed a person like Enno, who did a lot of good input in his presentation, but we were much more into the data level and not that much into the regulatory framework level, which would have been very interesting to add such an input into this session. We said, okay, one thing which the distribution networks could ideally do is to relieve all the congestions which are caused on the TSO level, apart from that ones which are caused on their own level. And of course, to contribute flexibility, which we already had in the discussion, in the presentation, in the first discussion about it. And on the other hand, there are a lot of problems on the regulatory level, so that this is not really working, and it's not already written down, but we couldn't define it on our own because we are not at all experts on this theme. And the third point, which we discussed much more, was that there is a big need of a better knowledge of all the detailed underlying data. So there's the wish that much more precise and regular exchange of information of the DSO and the TSO level should be enabled, so that they can develop more plausible and achievable scenarios. This was the main point of our discussion. And we found out that there are some people who are involved in the roadmap process, which is just set up right now, and where the TSO and the DSO are put together into a cooperation, and this will be presented at the Copenhagen Infrastructure Forum. And they try to set up a governmental structure for it, and they want to develop a better interaction on the working level. I hope that I got the points right. If not, I'd like to be corrected by my discussion partners.
Yeah, thank you very much, Franzi. I named it idly, so to get rid of all the regulatory problems. So you're doing well down to deep dive into this question, because I think everybody is aware that there's a lot of work to do. Yeah, this fits very well with my finding of today. I think I was impressed how much scenario work is done already on a DSO level, and how helpful it would be to get it somehow collected and available for others, especially for the TSO planning, as well as for the European planning. I think it could be very helpful for a lot of questions to answer, and maybe as well to get kind of synthetic models of a future grid out of that. And I think a lot of these also thinking already together gas and heat and mobility, so they could provide a very useful brick for our puzzle on the way to get better energy transition confirmed modeling of the future European energy supply. So now I want to ask you if there are questions from one group to the other, or as well between each other. And I see it's not a question, but Giuseppe offered to give more detailed information about his work on DSO observatory and distribution network model platform. And I think this is one of the reasons we do this workshops and this small groups, to connect people to each other. And I would be very happy if you would make use of that and ask questions to other participants. If you think that this could be helpful. And we want to bring people together and merge knowledge. So if there are no other questions and no comments, are there any comments, questions? Or maybe Giuseppe, you want to explain this on to the group and take over for a moment.
Yes, can you hear me? Can you hear me? Yes,
we can see you and hear you.
Actually, some time ago, I did this presentation for the Alan Turing Institute on our Dynamo platform. It is about synthetic networks. It's about distribution network, say, models, and is based on data that we have collected at European level from distribution system operator. In the sense, we are doing this exercise of data collection since 2014. And now we are working on the third edition on the Distribution System Operator Observatory. So the report is providing, say, an overview at European level based on all the data that we collect. And since these data are confidential, so we cannot share, some time ago, we decided to use this data in a smart way. And the idea was to use the reference network model methodology to build representative networks and to put all this technology in a platform, which is the Dynamo, which offer, say, based on how is it called, like Google Maps, the possibility to select an area of a city, which can be 2 by 2 or even 3 by 3 kilometers square, And you, based on the data that the user can input on this area in terms of density, population, in terms of demand and say supply in this area. So the platform is taking all the information say that DSO has provided for this area or for this say country, depends on say from region to region, is providing as output the network, the grid models of this area, and is using this well-established methodology called reference network models, which is at the core of the platform. So I think I can share with you the link, or just send you an email as soon as I found it. And there is the, say, this webinar, which is 1 hour more or less long. And perhaps if there are people interested in the platform, they can look at, can watch this video and clearly drop me an email if they want to know more about this project. Clearly, the idea is that if we have a user, or the process can have, say, more, say, exercises in the future year. If there are, say, a lot of people which are using and are interested in being this platform.
Yes, thank you very much, Giuseppe, for offering that. I think this is very interesting for a lot of us. Do you take into account some kind of heat delivery and sector coupling in this model?
No. At the moment, there is only, it's just based on demand, so electricity demand. So sector coupling is still not there. We have some project which is starting this year on sector coupling, but we are very, say, not there still. It will grow a lot, I think, in the next year. But the good thing is that if you have access to other networks, for example, EAT networks or something like this, you can use, for example, GIS and put the two networks together and really look at optimization of, for example, different vectors, energy vectors together. So I think it's something that is a layer and is there and is fundamental one, especially if we are moving to electrification of several sectors like heat and transport. So I think it's a key layer and it's fundamental to have it there. Yeah.
It sounds very useful. Thanks a lot. The other comments, questions, maybe ideas, what we should focus on if there's a next workshop. Wishes? Nothing. So then I will pass over to Antina to have some final words, and then we will close in time.
Yes, if you have feedback for us on how to make more interactive such a conversation, let us know. We all know it's not easy to sit in front of the screen all days long, but yeah, if you have any additional suggestions, whether you like the breakout groups, whether we should be doing something else, we'll be happy to hear your feedback. Other than this, content-wise, I think all of these conversations in each of the 4 workshops that we have done so far shows us we know we only get started in understanding how to model the complexity of the future energy system. And therefore, we as RGI really hope that we can continue to provide a platform for this type of conversation. How exactly will have to be seen. The PAC project itself, which up until now has served as the umbrella to these conversations, is coming to an end, and we are working on an extension. You can all cross your fingers for us. In any case, we keep you on the mailing list, because what is not coming to an end is RGI, and we certainly will continue to find ways to host conversations of this kind. And if we do, we will be happy to invite you, of course. If generally you say, I want to know everything that RGI organizes, sign up to our newsletter. I can add the link. We will share the presentations, we will share these slides. The video recording will be online. Have I forgotten something, Holger? No. Good, then thanks a lot for your time and hope to see you soon. Stay safe. Goodbye. Have a good day.
Bye.
Thank you.
Bye.
Thank you. Bye-bye.
Thank you. Bye.
Bye.